Welcome everybody. We have this question. We expected to write 7 raised to the power of 2002 as a sum of 3 non-zero perfect squares. So along the lines, we would like to invite everybody to come join us. In this channel, we are predominantly focusing on developing the mathematical mind, which in turn is responsible for making people successful, because everything is numbers and numbers related, because we are living in an age. Apparently this was foretold by Aristotle probably 2000 years ago, that the entire universe is comprised of numbers. So if all these things interest you, and if you have a passion and a vision and a desire to achieve something big, we would like to welcome you all to become subscribers of our channel. So having got that out of the way, let's move on. So we got this quantity. So our objective is to write this as a sum of 3 non-zero perfect. Let me underline that out. So foremost, what I wish to do, this is given, 7 raised to the power of 2000 is given. I would like to write this as 7 raised to the power of 2000 positive 2. I know that a raised to the power of m times, in fact, a raised to the power of m positive n can be written as a raised to the power of m times a raised to the power of n. This is the popular exponent rule. So by this I can rewrite this as 7 squared times 7 raised to the power of 2000. Now 7 squared is nothing but 49, so I've got 49 times 7 raised to the power of 2000. Now I can rewrite 49 as 36 positive 4. 36 added with 4 gives me 40, then I got a 9 here. So this has to be multiplied with 7 raised to the power of 2000. The question wants us to write 7 raised to the power of 2002 as a sum of 3 non-zero perfect squares. So I'm going to rewrite this as 6 squared, I'm going to rewrite this as 2 squared, I'm going to rewrite this as 3 squared, and this is going to be 7 raised to the power of 2000. But we have not reached our objective. On the left hand side I've got 7 raised to the power of 2002. On the right hand side I've got 7 raised to the power of 2000 multiplied with these components. Now the solution is not complete until I'm able to represent the entire quantity as sum of 3 non-zero perfect squares. So that is the most important part here. So I'm going to rewrite this as 6 squared times 7 raised to the power of 2000 positive 2 squared times 7 raised to the power of 2000 positive 3 squared times 7 raised to the power of 2000. So I've got a term, but I need to write them as a perfect square. So that is what is critical. So I'm going to rewrite this as 6 times, I'm going to write this as 7 raised to the power of 1000. Okay, that's fair enough, but this has got a power, this has got a power 2000, but I've got 1000 here, this has got a power 2. So I'm going to raise this entire term as a power 2. Right, fair enough. So I can follow the same pattern. So 2 multiplied with 7 raised to the power of 1000, that is raised to the power of 2, followed by 3 times 7 raised to the power of 1000 raised to the, this entire thing is raised to the power of 2. So fair enough, right? 6 squared and 7 raised to the power of 1000 raised to the power of 2, that's going to be 7 raised to the power of 2000. So clearly I have rewritten 7 raised to the power of 2002 as a sum of 3 non-zero perfect squares. So this is a beautiful result that we have achieved here. Thank you.